let's say we have a quadratic equation, right? Set equals 0, all that. So let's say we have the quadratic equation x squared plus 3x plus 1 is equal to 0, right? And it has the roots, right? I'm gonna call them alpha and beta. So suppose alpha and beta are the roots of this equation. My question to you is, what is the value of alpha squared plus beta squared? Right? Alpha squared plus beta squared equals question mark. What is it? What's its value? So this question really, it can easily be solved by knowing the formula for the product and sum of roots. So I think I'm just gonna remind you of that. So the sum of roots, right, for at least for a quadratic, the sum is equal to negative b over a, right? And the product of the roots, right, is equal to c over a, our constant term over a, right? So basically, we know our sum and product, right? I think what I'm gonna do, right? Well, you all know that the sum means alpha plus beta and the product means alpha times beta. Probably just like write that under here. So I don't know, just for reference, sum equals alpha plus beta, product is equal to alpha times beta, right? I don't know, I'm just writing it for reference, right? So we know the value of alpha plus beta, we know the value of alpha times beta, right? So what's the value of alpha squared plus beta squared? Well, the idea is, if we could maybe rewrite alpha squared plus beta squared in terms of alpha plus beta and alpha times beta, in terms of like some operations based on some operations of these, right? Then we can just plug stuff in and then find the value for alpha squared plus beta squared. So that might not make much sense, but watch what I'm about to do. So alpha squared plus beta squared, I mean, I wish it was equal to alpha plus beta squared. That'd be nice, right? That's like the classic algebra mistake where you say alpha plus beta all that squared is equal to alpha squared plus beta squared. But in this case, right, so if I were to write alpha plus beta all that squared, that expand out to alpha squared plus beta squared, well, alpha squared plus 2 alpha beta plus beta squared, right? So if we were to subtract 2 alpha beta, right, that would be equal to alpha squared plus beta squared, right? So we just basically did it, right? Alpha squared plus beta squared. We re-expressed it in terms of an alpha plus beta and alpha times beta. Now we can just plug stuff in to get the answer, right? So let's see here, alpha plus beta. Let's see here, sum equal alpha plus beta. Oh, sum is equal to negative b over a, right? So negative b over a is equal to negative 3 over 1. So that's negative 3. So alpha squared plus beta squared is equal to alpha plus beta. So negative 3 squared minus 2 times, all right, what's alpha times beta? Alpha times beta is equal to c over a, which is equal to 1 over 1, which is just 1. All right, and that's easy. We can just evaluate that. So minus 2 squared is 9. 9 minus 2 times 1, so that's 9 minus 2, which is equal to 7. So that's our answer. Alpha squared plus beta squared is equal to 7. So really, not that bad of a problem. I might have confused you a lot by kind of yapping a lot, but main gist is rewrite things in terms of alpha plus beta and alpha times beta, right? So, yeah, not too bad. So stay tuned for more cool stuff.